All right, I think we are live. Welcome everybody. I had some technical difficulties just before the stream setting up. For some reason my mic was not working and then my camera was not working and then nothing was working. So I do see, it seems like in OBS that everything is working. I see a green bar on the mic, but if for some reason you can't hear me, please let me know in the chat. Otherwise, let's just get started. So the topic of today's stream, we're gonna try to build sort of a real thing. We're going to build a small command line application that can sort of walk you through all the Git branches that you have in your project. And the idea is that it'll show you when the last commit was, and then you can delete the branch if you want to, and then it'll sort of walk to the next branch. So it's going to be sort of an interactive command line application. So that should be fun. We're going to do it in Rust because that's cool. The idea is not to build something amazing that has never been built before. I think building sort of like small command line tools for yourself as like toy projects is a great way to get familiar with the language. That's how I started learning Rust in the first place. And I think Rust is a great fit for command line applications just because it's really fast. And getting sort of, we're going to see today that there is a library for Git called libgit2, and the Rust bindings for that are really great. So you don't need to like shell out to the terminal all the time, which is kind of cool. So let's just kind of get started. Let's make a new, by the way, you're going to see me type CA a whole lot. CA is just an alias that I have for cargo. So cargo new, we're going to make a binary. And let's call it delete git branches. Can always change the name later. And so right off the bat, we're going to use a couple of libraries. There is a library for Git called Git2. If you just search for Git, it says use Git2 instead. So that's what we're going to do. And looking at this library, first of all, it's a good sign that it was updated recently, so it does seem to be an active library. And also, whenever you see this guy in the list of maintainers or owners of the library, that means it's probably high quality. This is Alex Creighton, and he's done lots of work on the Rust project. So this is a really great library. It's basically bindings to the Git C library. That lets you basically do everything that you can do in Git, but sort of through Rust, which is really nice. So the sort of main type that you interact with is this repository thing, and it allows you to open a repository. You can get an iterator over all the branches and get the commits and all these things. So let's go ahead and add that to our project. By the way, is there any questions about what we're working on, or is everybody good? You can like put questions in the chat whenever you want, and I'll see. Well, I'll make sure to get to them. And it is that I'm going to sort of try to build it as if it was a real thing. So we're going to actually take care into how we do our error handling, and we're not going to do unwraps and expects all the time. So hopefully you guys should get sort of an idea of what it's like to actually build a small application using Rust. Now, another library that we're going to need for error handling is this error. I'm just going to add that now, and then we'll get to it later. It is just that we shouldn't have to like compile all the dependencies all the time. We're also going to need crossterm. Crossterm is a library that basically lets us interact with sort of the terminal in like a cross-platform kind of way. We're not going to need a whole lot of this. We're basically only going to need one thing. But if you wanted to build like a text editor in the terminal, you could use this library. So it has all sorts of things to deal with the cursor, to make colors, clear the screen, all sorts of cool stuff. There's a couple of libraries that I found that do this. I found that crossterm is the most sort of well-documented library. I was playing around with how to do this yesterday, and I tried out a few different libraries. And crossterm seems really nice. is there anything else that we need? Yes, we need chrono. So chrono is a library for dealing with like dates and times and stuff. We're basically just going to need this to format the time of when a commit happened. I don't think we're going to use anything else. All right, so the very first thing that we're going to do is we're going to talk about how to actually view your documentation. So in a Rust project, you can run cargo doc, and that will compile HTML files for all the dependencies in your crate. You can also do cargo doc no deps, and that'll compile just the documentation for your current crate. It won't like include dependencies, but in this case we do want dependencies. So if you do cargo doc -open, it'll open the documentation in your browser, and here you can search through the docs of all your dependencies, which is really nice. So you have sort of one way to search for anything that you have access to within your crate. And there is a project called Cargo Docs Server, I believe, which is basically a small wrapper around Cargo Doc that lets you run a web server, so that you can easily get to your docs and you don't have to type cargo doc open all the time. I made a small patch to that. It's currently just in a fork, where if you hit enter, it'll like recompile your docs, which makes it very easy to whenever you've like imported a new crate or you've made substantial changes to your own library, then you can quickly recompile and look at the docs that way. So we're gonna run that. That is cargo docs server, and then it runs like that. And so here is, why is it always white? Let's make it dark. So here we can see all the docs. So the very first thing that we're going to deal with is the stuff that we get from CrossTerm. So the sort of UI that I imagine that we're going to have is a way for like to show some question to the user, and then like have a little prompt thing, and then have them like type a single letter here. So the idea is that it'll like show some SHA of a commit and be like, or like a name of a branch. Let's just say some old feature, and then it'll be like what to do, and then you can say keep, delete, question mark for help, or show the commit, or whatever. And then the user will type like one letter, and then we'll like do stuff down below. So this is the very first thing that we're going to do. Actually print a prompt to the screen and have the user type in one letter. So let's do that. If you go to the standard library in the IO package, the IO module, there is like code for reading files and writing to standard out and standard error, getting input from standard in, all this stuff. There is a function called standard out. If I could type standard out, that lets us write to the screen. You can also write with like println, the common macro that we use, but this is sort of, that basically calls this standard out. Let's do that. So if we want to get one of these, there's a function called stdout. Let's first import use IO, and let's say IO stdin stdout, like that. And then we can actually write to the screen like this. Write all. Out. And so write all returns a result. Wait, first of all, we have to import it. Hello again. How's everybody doing? So this write all method is a method on the standard IO write. So if we load up that trait, write, you can see that's where the write all method comes from. And you can only call methods that you have in scope, or where the trait is in scope. So that's why Rust tells us to import it. So let's do that. Next up, we can't borrow standard out as mutable. It's easy, let's just declare it as mutable. Coding's going good so far, we're just getting started. Next up, it tells us that we have a result that we're not using. So you can see that write all takes a slice of bytes. This is syntax for a slice, so basically an array of any length, we don't really know. And U8 is the byte, and it returns a result. Now, if you click on it, you can actually see what this result is. So it's just a type alias for a result of some type T, and then an error where the error is an IO error. So this is just sort of a convenience that you very commonly see in libraries, where if you have a result with some specific error type that you often use, you make a small little alias to basically wrap it like this. So here, for now, we're just going to say unwrap. We are going to remove this later, but this is just to see that things are actually working. Let's go ahead and run this. It's going to compile our dependencies. Hopefully it will all work. And there we go. So it is actually working. And the reason we see the % sign at the end is because we don't finish with a new line. So there we go. This is sort of the sort of one of the rather low-level ways that you can write to the screen. You can of course also just do this. That works too. But for this application, we're gonna want to do this, and it'll be clear later. What got you started writing Rust? I don't actually remember. I've been writing Rust for a couple of years. I think I just kind of heard about it, and then I looked into it, and it looked really cool. I wrote a lot of Haskell back in the university days. But Haskell never really struck me as like a super pragmatic language that you would actually do real work in. So Haskell, the Rust's type system is sort of inspired by Haskell, which was like one of the things that actually sparked my interest in Rust. No, I've never done any Go. All right, so now we're able to write to the screen. Let's figure out how to actually read from the screen. So there is a function called stdin that returns a standard in. Let's make one of those. stdin is IO standard in. And this implements the read trait, which is a trait you commonly see. This lets you basically read from standard in, from a socket, from a file, from a string, from whatever. And crucially, it has a method called bytes that transforms the read instance into an iterator over bytes. So what we're actually interested in is when the user types like one character, we want to capture that immediately. And that is basically capturing 1 byte because a character is just a byte. So we need the bytes method, and that again comes from the read trait. All right, so we have an iterator over bytes, and we can see this is basically what we're doing in the documentation here. So then we can say for byte in standard in. Let's print it using the syntax that we had before. Byte. So currently it's complaining that it expects a vector, or rather a slice of bytes. What we're giving it is a result. So it seems that this bytes iterator, if you expand this line here, you can see it implements iterator for bytes, and then you can see what is actually an iterator over. So it's an iterator of a byte or some IO error. So we have to actually say byte is byte unwrap. And now it's telling us that it expected a slice, but it got a single byte. So let's do that. And this actually compiles. Let's try and run it now. So now it's not doing anything. It's basically waiting for us to type stuff. So if we try to type A, we see that nothing happens. And this is a bit surprising maybe, because we're like iterating over the input 1 byte at a time, but it's like nothing's really happening. However, when we type enter, then we can see that then everything is printed. So there's some weird thing going on here. And so this took me a while to figure out, but what I learned is that currently our terminal does a whole bunch of stuff behind the scenes for us. It basically buffers the input and only sends it to the application, or rather the currently running process or whatever, when there's a new line. And this is why we're only seeing, our application is only getting the input when we hit enter, and that's not what we want. So what we somehow have to do is basically tell the terminal to not do that buffering anymore. And the way you do that is by enabling something called raw mode. And if we look in the cross-term crate that we pulled in, I think we lost, there we go, our local docs, cross-term. It has in terminal, it has a function called enable raw mode and disable raw mode. And these are exactly what we need. So let's call that at the start of our function. This also returns a result. And this is another one of these type aliases with a sort of common result type. Let's not worry about that for now, just unwrap it. And then at the end of our program, let's also disable raw mode. And let's try this again and see if that changes anything. Which it did not, because we don't see anything. But I can't like quit. I'm hitting Control-C, but like nothing's happening. So let's just force quit it like that. The issue here, I believe, is that we have to actually still tell standard out to flush. So it will still, like when you write to a writable thing in Rust, basically, it buffers the output. And then only when you tell it to actually flush does it, that's when it does the write. So this is the method that we're basically calling this flush thing. Flush this output stream, ensuring that all intermediately buffered contents reach the destination, which is the destination in this case is just the screen. And that returns a result, so that's why we have to unwrap it. Whoops, I do believe it should work now. Yeah, so now it's actually typing. And the reason, I still can't quit, god damn it. So the reason that as I was typing, we basically just saw the character, that's because we read a character and then we just write it straight back. Let's try to actually turn it into a character, and then let's sort of print some extra text around it so we can see that things are actually working. So currently, this byte is just a U8. We can convert that into a character by saying char from. Now it's a character. The reason that we know we can do that is on the char module. Or rather, I believe it's on the char type itself. Down here, yeah, we can see it implements from U8 for char. So that means that we can get a character from a byte, basically. And there's a whole bunch of like caveats and stuff here about encodings that I don't really understand. But I mean, it can't fail, so I suppose it works. So let's say this is now a C. Now you can do this syntax, but actually what you can do instead, so this is a bit annoying, like write all takes bytes, and actually I suppose Like we could perhaps like turn the character back into a byte, but like really, since we want to like basically interpolate it with string input, we can use the write macro. Why don't you use fancy question mark syntax for results in Rust? We're going to get to that. Currently, we're just sort of getting things working, but we're going to get to it very soon. Don't worry. So write is basically a macro that lets us write to a writable thing and also do like string interpolation. So you might have seen println, where you can do string interpolation stuff here. Write is basically the same thing, but where you can specify what you're writing to, like that. So now we can say write the character, like this, and then we can say you typed, and then the character. And we still can't quit it, but as we can see, we're forgetting the new lines, but stuff is working, and we're successfully capturing the one character and not showing it. Still can't quit though. Let's address that just now. Let's say if character is Q, then we break out of the loop. We could probably figure out how to handle Control Z and stuff like that. Let's not deal with that for now. So now it actually captures, and now I have a Q. We'll get out of there. Let's add a new line. Let's just add a new line at the end here. So this is weird. It doesn't like, it goes down one line, but it doesn't go over. If you've ever dealt with terminals in raw mode, you probably know what this is. So that for some reason the terminal protocol is very old. And actually the \n in sort of tell it type whatever 80s style ways, \n only means go down like one line. If you imagine that you had like an ancient machine with actual like type heads and like a thing that you roll and all that stuff that's in the museums, you have to both go down, or rather roll the paper thing, whatever, and also move over all the way to the left. So that's what \r means. If you've ever done programming on Windows, you've probably seen a lot of these. So this means go down one line and go all the way to the left. And now this looks promising, right? So now we see what people type, and we can hit Q to quit. And then we can basically add a small prompt. So we can say write to stand it out, type something. And notice there's no space here, so the user's cursor will be left in this position, right? We get a character if they type quit. Otherwise, we tell them what they typed, and then we flush. I think we need to flush here as well. Let's try not to, just to see that it doesn't work. Yeah, it doesn't. And then I believe when we type, then we actually see it. So that's what we want there. No. Is that because, do we need to do it outside the loop? Yeah. All right, so the issue is that this for loop, a for loop is basically the same. So if we look at the iterator trait in Rust, a for loop is basically the same as calling next on an iterator until it returns a none. So a for loop is basically the same as saying while let some byte is standard in next, like that. And then I would have to make it mutable. So that means that as soon as we do this line, then we call next on standard in, which means it blocks and waits for the user. So that's not actually what we want. what we want to do instead is enter an infinite loop, then print our input, then say that the byte is bytes next. In this case, we need to unwrap twice. This is standard in. And the reason we need to unwrap twice is because next returns an option. And it would never return a none because like you're always going to be getting more input from the keyboard. And then the reason that we need to unwrap again is because this bytes iterator that we have yields results inside it. So we're unwrapping the option from the iterator and then the result. So this, I believe, should work. There's our prompt, and then we can type. And the reason it quit is because I hit Q. All right, so now we can sort of build a small terminal application almost, which is kind of nice. But as people addressed in chat, let's deal with these nasty unwraps. There's way too many of those. So let's get rid of those. The way that you do that is using the result type. And it's actually really cool. In Rust, you can return a result from your main function. And then if the function returns OK, then the program exits successfully. Whereas if it returns an error, then Rust will print the error and exit with a non-zero status code, which is really nice for sort of wrapping your whole program in a try-catch kind of thing almost. The question is though, what is our error type going to be? If we just sort of say, I don't really know, it's just whatever enable raw mode returns. So remember this enable raw mode returned a result where the error type is a cross-term error kind. So let's say that's what our result is going to be. Apparently that works. We can disable this down here, and this works. And by the way, for those who aren't familiar, this question mark syntax in Rust is basically equivalent or sort of syntactic sugar for doing a match on this expression and then saying if it's okay with a value, then return that. Otherwise, if it's an error, then return that error. So we're basically sort of returning, if we encounter an error, we basically just return it to whoever called us, which in this case would be sort of main itself, and then we return an error from our entire program. So question mark is basically a super convenient way to bubble up an exception, basically. So everything's good so far. Let's bring back our code sort of slowly. And let's try to bring this one back. So now this unwrap, we don't want anymore, so we change it to a question mark. And that worked. I was expecting an error there. Let's see. So if you're ever curious, like what type something actually is, if we just ask Rust Analyzer, it says it's an error, but what error is it? Where does it come from? So we can just bind it to say, hey, it's a type unit, and that's obviously going to fail. And then it should tell us exactly what error type it is. So it's a std result of nothing or an IO error. And so the reason that that worked is a bit subtle if you've never done Rust before. So notice that I promised to return a cross-term error kind, but this down here, like we just agreed that the question mark just returns whatever error it gets. Like this, right? If I can vim correctly. So, like, why does this not compile? But using the question mark does compile. curious. The reason is that question mark does a bit more than just this, actually. What it actually does is this. And this now compiles. So we've actually already seen this from trait. We use it down here, char from. So from in Rust is a built-in trait to the standard library, and it allows you to basically convert between types. So you can see that from is implemented for some type t, and it takes one of those t's and then it returns a self. So in this case down here, where we convert the character, or rather the byte, into a character, we implement from byte for character. So this t in that case would be a byte, and the self would then be the character. So what this does is you can basically think of this as calling as almost implicitly converting the sort of inner error into a cross-term error. And the reason that we can actually just type this is because Rust can infer that, well, this from is not a type, from is a trait. So you can't return a from. Rust has to actually know, well, which from function should it actually call. And so the way that Rust can infer that is from this, from the fact that we've written the return type up here. So it's basically equivalent to doing this. And I guess it just so happens that cross-term error kind actually implements, so I guess one of these, yeah. So this first one, from error, which is an IO error. So you can already create an error kind from an IO error. And we can see that probably all that it does is just wrap it in this variant right here. If you click on source out here, you can see that. So, okay, it's actually implemented by a macro. I don't know exactly where that macro is called. Probably not. Apparently not called in this file, but it is definitely called somewhere, right? So that is why that just sort of magically works. Does that make sense? Any questions about how that conversion works? If I'm going too fast, just let me know and we'll slow down. So this is the fact that we can use question mark to automatically bubble up errors, and the fact that it sort of implicitly calls from to do conversion is a thing that we're going to use a lot when doing error handling in Rust, because it allows us to basically take library errors and wrap them in our own error type, which is kind of nice. So that was that question mark there. I believe this one will go away the exact same way. Yep. So this unwrap is in case there is no character. Let's just pull it out to a variable. Let byte. So this unwrap is on the option, whereas this second unwrap, whoops, is actually on the result. So we can remove that. Notice that we cannot do a double question mark here, because in this case it's an option, and you can use question mark on option, but that requires that our function returns an option, which it doesn't. So for now, let's say unwrap question mark, and that works. However, we don't actually want to be having this unwrap. We know that our application won't ever like run out of input because it's reading from the keyboard. But let's just be a good citizen and actually handle it if that ever happens someday. So let's do a match. Say match, no unwrap anymore. If we get a sum byte, then we return it. If we get a none, then we'll just break from the loop. So now byte is a result. And now, I think we can actually use question mark here. So we have, this works, we have our character. If it's Q, we break. Like that. the same. There we go. So now there's no more unwraps anywhere, which is nice. And let's just make sure things are still working. It seems like it. We can hit Q to quit. Sweet. Now, it's lucky that we were basically able to return cross-term error kind. Normally, you cannot take errors from two libraries and just sort of convert between each other. It just so happens that we could do that in this case. Normally, you can't. So let's actually make our own sort of umbrella error type, and we're going to be adding like Git-related errors and stuff like that to that type later. So it will be necessary at some point. So the way that you normally do that is you have an enum. Let's just call it error. And the enum will then, very similar to this guy, have a case for each sort of low-level error that can actually happen, and then wrapping that inner error. So in this case, we can wrap a cross-term error with that contains a cross-term error kind, and it also contains an IO error, like that. So now we basically want to say that this error that we just defined, that is now the error type that our main will return. And now we're getting a whole bunch of errors. Let's focus on them one at a time. The first one, it says that error cannot be, let's remove this question mark as well. So it says that error cannot be formatted using this syntax, which is basically syntax for calling the debug trait. So we have to implement debug for error, which you can do by just deriving it, like that. So next up, it says that we can't convert from a cross-term error into our own error. Because remember, this is what the question mark sort of implicitly does. So let's go ahead and implement that. Let's say impl from cross-term error kind for error. And then if we look at the trait definition, it looks like this. So it takes a t, and a t in our case is whatever's between the square brackets. So that's this. And then it has to return a self, which for us is an error. You could also write self, but let's just be a bit more explicit and say what the type exactly is, like that. So what we basically want to do is just wrap it in one of these, like that. And there we go. So this actually compiles now. I'm honestly a bit surprised that it doesn't complain that we don't implement the error trait. I imagine we might see that crop up later. I guess just from the fact that it's inside a result means that it knows it doesn't need the thing to implement error. But if you were making a library and you actually wanted sort of a true error type, you would also have to implement the error trait that's in the standard library. And that's actually very easy to implement. If you look at the definition, you can see there's actually default implementations for all the methods. So basically, you have to make sure that whatever you're implementing this trait for already implements debug, which we already do right here, and that it also implements display. And display is sort of the other version of the debug trait. It's just the one that does human readable printing, basically. Whereas debug is pre-printing for programmers, basically for debugging. So let's implement display for our error type. There's this nice little snippet here that we can copy, format it. We have to import FMT, and we're not implementing it for point, we're implementing it for error. And now, depending on which variant it actually is, the implementation is going to be fairly simple because all these types are errors already. So we can just match on which sort of actual error we're getting and then delegate to the inner error. So let's match on self error. If it's a cross term, we'll say inner. And then what you actually do in the middle is just use this write syntax that we're already using up here. So in this case, we're writing to some f, which is a formatting thing. Like that, and inner. And we also have to handle IO error. That's handled the exact same way. So there we go. Now we've implemented display. So now we should be able to directly implement error. Let's say impl sc error for error, like that. And that's basically all we have to do. There is the one method here that I think we should be a good citizen and also implement. It's this one called source. The lower level source of this error, if any, which in our case, we do have actual sources for both of our errors, is not hugely important for the small toy project that we're building here. But if you are actually making a real library, this is something that you would want to do. So let's go ahead and override the source method. We can basically steal this implementation. We're gonna have to do a match again. I'm following the official Rust book and I just got to chapter 5 structs. Very interesting so far. Yes, this stream might be a bit too quick for you, but you're welcome to stick around. I do expect that you've read at least a fair bit of the book. But if you have any questions about what we're doing, just put them in the chat and I'll do my best to answer them. I believe this is what we want. Some what's it saying? The trait error is not implemented for reference IO error. Consider removing one leading. All right, so that compiles. I mean, the compiler basically told us exactly what to do, which was really nice. I'm still a bit confused with ownership, but I'll get used to it. Yeah, ownership is Rust's most novel feature, I think. I think the book does a good job of explaining it, but it definitely still takes some time to actually get it into your fingers and write some Rust code to really get used to it. So now we should be good to go with regards to our error type, and all this code should basically still work, except we are missing the implementation of from IO error for our error type. Let's do that. It's very boilerplatey. So this is IO error, IO error, IO error. There we go. Now it compiles. So this works, but as you can see, it's quite a lot of code just for error handling. It's what, like 34 lines, and we only have 2 cases. So for each case, we're going to need a new from implementation, and we're going to have to update the display method, and we're going to have to update the source method. So this is where the crate that we pulled in at the very beginning called anyhow. No, this error. This error is basically a trait, a procedural macro that lets us derive all this stuff and make error handling, sort of having our own custom error type, super easy to do. So this is sort of what it looks like. You can put derive this error on your type. Let's just comment all this out like that. And then inside these attributes here, on top of each implementation, you can write the text that goes inside the display implementation. So this guy down here. And you can also, if you annotate it with from, then you'll get a from implementation, similar to what we did before. And you can also annotate them with source, I believe. Yep, like this. And then it'll put it inside the source implementation for the error trait. So the way that we basically want this to look is we can just use this error transparent, which will basically directly delegate to the error that's inside for this guy, the display implementation. So this is transparent and like that. So that works almost. We're just missing this from annotation on the inner type, like that and like that. And now we're back. So we basically get all this code for free. And next time we add a new error case, well, we just add it here, and we can include whatever annotations we want. We can also just say, write our own, like that. And now we basically have a new error case. So this crate, this error by the same guy that makes Cerde, actually, the serialization and deserialization library, is super handy for doing error handling. He does have another crate called anyhow, I believe. So pro tip, if you go to docs.rs, which is the official documentation for all Rust crates, you can go to /docs.rs/ like the name of any library. So for example, anyhow, and it'll just pull up the latest docs for that library, which is really convenient. So what this basically does is it lets you sort of not care about having to define an error enum in the first place. You can just take all error types and basically wrap them into one generic error type. It means it's a bit annoying to figure out what the underlying error actually is. But if you're building like some application that for whatever reason doesn't actually care about what exactly the error is, maybe you just want to report it somewhere and tell the user, hey, this thing went wrong, but don't care specifically about what the type is, then anyhow is super convenient to use. Which like we could totally do that for our case, but I figure showing how to actually make our own error type is a bit more interesting. This is also, if you were to make a library, this is definitely what you would want to do. Because if you were to return these errors to your users, they would have to basically manually call some of these downcasting methods to actually figure out what error type is inside this error. So we can remove this import. Right. Any questions so far? We just ran through quite a lot of error handling. Any questions about how the macro works or anything? Otherwise, I think we're going to move on to the actual Git stuff. So you can basically imagine that we're going to have some sort of a loop that will basically have some application state, and then we'll perhaps ask the user for some input, and then do stuff like call into this Git library that we're going to be looking into, and then call back to the user. And everything that we sort of need to do that is already here. So the next step for us, I think, is the Git stuff. So let's comment this out so you don't accidentally run it. So many tabs. So the library that I imported before, called git2, is basically sort of bindings to the cgit library. So the way that you get a repository is the easiest way, at least. Repository is to use this open from env function. So it does some stuff where it looks for like magical environment variables or whatever. And then it says with git your unset, which I guess it is in our case, this will search for repositories starting in the current directory, and then it'll basically search in the parent and in the parent and in the parent until it finds a .git folder. This is a very common or very easy way to open a Git repo, basically. Let's actually let's just comment out this whole main function, and let's just make one more. Say let repo is repository. Now we need the question mark again because it returns a result. In this case, the concrete error type inside it is this git2 error. So we have to import repository like that. And now we basically need, it's again telling us the error that we got before, that it can't convert a git error into our own sort of umbrella error type. That's very easy. You basically do that, and now it works. So this is why I really like this macro, that lets you super quickly add new error types. So that compiles. Now we have a repo. Now we say, let's say that we want to know like all the branches and when the last commit on that branch was made. So if you just search for branches, you can see that repository has a branches method that takes some filter branch type, where a branch type is either local or remote. I actually don't, if you pass this none, set this to none, I don't exactly know what it'll do. Yeah, it's not very obvious from the code really what it does, because it just kind of calls like into some C stuff. It does like unsafe stuff. But anywho, it returns a branches. And we can see that branches implements iterator, where the item is a result of a branch and a branch type. And again, branch type with this thing that we saw just before, where it's a local or remote. I suppose if we set it to none, it returns both local and remote branches. And then on a branch, we can actually getting sort of, you have to sometimes search a bit around for this library to figure out how to actually do stuff. But I believe a branch has a method that returns a reference. And then I was looking into this earlier today, and then the reference has the name, so that would be like the SHA-1 hash. I'm not sure if this is where, I believe name is also here. Yeah, so that would be the name of the actual branch. The reason that this is an option string is because all strings in Rust are UTF-8s. And in case you have some branch that is not UTF-8, we can't really represent it as a string in Rust, so then it would be a none. Then you could get the actual bytes and then show the bytes however you would want. Let's just try to do that and see if we can figure out how to do that. And then we'll get to actually figuring out what commits are on a branch next. So on our repo dot branches, a none. So remember that was this function here. We just set the branch type to none. Let's see what it does. It returns a result of branches. And then branches was this iterator thing. That means we can say for branch in, like that. And it's again an iterator of results. So let's say branch and branch type. That. And call name, which is again a result, name, And Rust Analyzer doesn't know what type it is. We can just say it's a unit, which will make it complain and tell us what type it actually is. So it's an option string. We actually don't need to care about UTF-8 or not. If we just get the bytes, we can just print those bytes directly. So name bytes. Then we can say, can do this similar business we did before by grabbing standard out and then saying standard out, write all name, like that. So remember, these are now a slice of bytes, and that's exactly what write all takes. And I believe that will print the names of all our branches. It did not. That's probably because we haven't committed anything. It's just no head here. Yeah, there we go. So there's our master branch. I've prepared a small example. A repo that we can actually play with that has a bunch of branches in different, with latest commits at different times. So if we, do a build, and we just run this from over here, target, debug, delete, there it actually prints all the branches, and it prints them all smushed together. Let's go ahead and just add a new line, write. We don't need to add \r now because we're not in raw mode. Do need to rebuild though. So there we go. So these are all the local and all the remote branches. Let's say we don't want to deal with remote branches for now. So let's say this one is a sum. What did it have to be? Branches. I got a question related to what you're doing, but is to Rust, can I ask? Yeah, go for it. As long as the questions are not too random, I don't mind. So we have to pass in an option branch type. Let's say local, branch type local. We have to import it like that. Build, switch over here. There we go. So these are all the branches that we have. Now we would like to know, well, when was the last commit made on that branch? Because I figure we would like to tell that to the user and maybe say branches that have been committed to earlier than last week or maybe 2 weeks. We don't even want to consider to delete. So that's what we're gonna do next. Why can't I do this in Rust? Struct x stir. All right, that's actually a pretty good question. Let's look at that. If we just comment out our previous code, struct foo y stir. So h is a foo. Like that. All right, so the first problem is strings is a bit weird in Rust. There's two kinds of strings. There is a capital S string and then there's a stir. This is normally called a string and this is called a string slice. This guy, a string, is basically evacuate. So a list of bytes. I actually think that if we look in the standard library, I don't know where it went. There it is. If we look at string, and we say, show me the implementation, you can see that this is the string in the standard library. It literally is a vector of bytes. And so a vector is a list that can grow and shrink in length. And the way that it can grow and shrink is because it allocates its contents on the heap. So what a vector actually is well, a couple of things. It's a length, so the size of the array, and then a pointer to, in this case, some raw vec, which we can't really see what it is here. So a raw vec is basically, again, you can think of it as like it's basically a contiguous piece of memory on the heap, and then what you have is a pointer to where that memory starts, and then you know how long it is. And there's also some code in here to actually track the capacity of how large your vector is, but whatever. The key is that this stuff is allocated on the heap, and therefore it can grow and shrink in size. What a stir is it's an immutable string. You can't change this without copying it first. And you can think of that as basically a pointer into another string. So if you type like this, and now S is one of these. So in this case, we have a string literal. And what that does is when you, I don't know how much you know about that, and I don't know a whole lot about it myself, but when you compile your code and it actually creates a binary, there's separate parts of your, like in different places in that sort of binary blob of data. And there's one section that just stores strings, basically. So what you can think of it is Rust, the compiler, is actually putting this foo string into the binary itself, and then giving you back a pointer that points to that binary, to that place in the binary, basically. So there's no such thing as just a stir like this. You always have an ampersand in front of it, or you have a capital string like this. These are the two kinds of strings there are. So this one is allocated on the heap, and this one is possibly allocated on the heap, but also not necessarily. So that fixes the first problem. So Y is one of these. And we're missing a lifetime. Let's just say this is static. Static just means that it lives for the entire duration of the program. I'm not sure we need to get into that now. Make an H, that's a foo. And then if we make this guy assignable, or mutable rather, now we can actually assign it to that. Hopefully that answers your questions. I believe there is a chapter in the Rust book about strings, but I agree the fact that Rust has 2 string types is very foreign when you come from other programming languages. Usually there's just one string. And in those languages, when you're like in Python or in Ruby or in JavaScript for that matter, if you have a string, you have the capital S string. So any string in JavaScript is a capital S Rust string, basically. Whereas in Rust, you get to choose what kind of string you actually want. Does that make sense? So the key here is that whenever you have an ampersand stir, you can think of that as a view into another string. All right. So where were we? We're able to print our branch names, and now we need to know where, like what's the latest commit and when did that happen. So if we go in here, iterator, branch, and so in terms of like lifetimes and stuff, you can see that many of these Git types have a tick repo at the end. That basically means that they are tied to the lifetime of the repository, which kind of makes sense, right? You can't sort of have the branch probably contains pointers into stuff that lives inside the repo. And if the repo were to go away, then the branch would also go away. So in terms of ownership, that's what that means. That basically the branch can't outlive the repository. So now we're like, I would like to know, say, what the time of the commit is. There's no like time thing here. There is one though that's like get that returns a reference. Let's look at what that has. So a reference has is branch, note, remote, tag, kind, and name. Let's try to print that out just to see what it is. Let reference. We can't call it ref because ref is a keyword in Rust. Branch get. It did not return a result. Nope. It just returns a borrowed reference. And then that has a name. Has name bytes. Name bytes. Let's print a new line. Build. All right, so this is, yes, we're getting closer. So it says that this Emacs branch is actually just revs, heads, Emacs. And if you look in the docs, you can see there are all these methods that have to do with peeling. So I didn't know what that was when I played around with this yesterday. And it turns out that you can basically have, in Git, you can have references that point to other references. So what a peel does is basically follow one pointer, basically. So if you have this branch that's pointing to some ref whatever thing that is itself pointing to a thing that is pointing to a thing, it allows you to basically follow that trail, basically. And so there's this method here called resolve that basically sort of peels away all those layers. So that is what we have to call. So branch.get.resolve, resolve, and that returns a result. So we unwrap it, or we handle the error. Build, run, still not. Is that the wrong one? Is it target? Get the OID. So OID is this, I believe it stands for object ID, whereas an object is maybe like a commit or something. I think that's what it was. I played around with this yesterday and I think it should work. Maybe resolve was one of the things I tried, but it didn't actually work. So sometimes you just sort of have to like scour through the docs of some library that you don't quite understand and try different pieces to see what works. So we're able to get an OID. Let's give that a shot. Target. Branch. Target. Let's unwrap it. For now, we're going to deal with that later. Oh yeah, that was on the get. So get returns a reference, and then target returns. It's annoying that Rust Analyzer doesn't know what type it is. And target returns an option that gives us an OID. So an OID doesn't really give us much. It implements as ref u8. As bytes. View the OID as a slice 20 bytes in length. Is that the actual commit? What I'm looking for is a way to basically get the commit hash. OID dot as bytes. You could peel to commit, I think. Maybe. That was definitely not the right one. Let's see, resolve. What was it called? Whoops. Reference. Peel to commit. That returns a commit, which has a time. Does it have an ID? It does. Commit. Is ID where the SHA is? Because let's try. So that's a commit. Commit ID. Turn no ID. Name bytes. Add bytes. Read the comment under ID. Get the SHA-1 hash of repository commit. That is what we want. Commit impulse display. Does it? Impulse debug. OID impulse display. That's probably what you were referring to. ID. Yes. Very nice. All right, so that actually does match 61A48. That's there. Yeah, it's always great when you're like watching a stream of someone struggling with a thing and you know what to do and you're just like, just do this one thing, just use display. What are you doing? So coming back to the struct thing, then it's much faster to use static str instead of string from because it's saved on the stack and the later on the heap, right? Yes, so whenever you do string from, that will basically allocate space for a new string on the heap. The same thing if you do like .toString, then it will also allocate on the heap. Sometimes an actual string that can change in size is what you want, but if you're able to use a static string, that will make your program use less memory. It's very sort of an easy way in the beginning when you're learning Rust to get around some of all the ownership stuff by just cloning everything all the time, which is totally fine in the beginning if you're just learning. But eventually you want to sort of get to a point where you understand ownership enough that you don't need to be copying all the time because you will be wasting memory basically. But it takes time to learn, and it's totally fine to just copy or rather clone all over the place in the beginning. We've all been there. I'm curious though if we can see how this display implementation for OID is, what method it actually calls. Oh well, it does unsafe stuff. This is not super helpful. Oh well. I was just wondering if there was like some super easy method that we could just call to get the thing, to get like the name that we actually run it. Although, no, whatever. All right, so now we're able to get each branch and its corresponding ID. Then let's figure out when was the last commit. So this thing was a commit type, and it had a time. Get the commit time, committer time of a commit. And this does us get the time in seconds since epoch, which is January 1st, 1970. And then let's guess the time zone offset in minutes. So let's do that. Let's say let time. And then I believe in Chrono, which is the date time library that we imported just earlier, they have two kinds of time. Basically, they have these date times and date, I believe, as well. And they both carry a time zone as a generic type. So you can sort of treat, or basically, I haven't used it that much, but it's pretty cool how it can basically do automatic conversions between the different time zones, I believe, which is kind of nice. However, they also have naive date and date time, which are basically sort of the same, but without that generic time zone on it. Naive date time, like that. So here there's no time zone. And I do believe there is a from timestamp. Makes a naive timestamp corresponding to a UTC date and time. Non-leap seconds, blah, blah, blah. This seems to be exactly what we want. So let's try that. Let's say use. Now Chrono has a whole bunch of different traits, and it has a module called Prelude, which normally when you do Chrono stuff, you just import this one. And then we get the naive date time, which is the type that we actually need. So let's import that. Chrono Prelude. We can say naive date time from timestamp. From timestamp. That takes a number of seconds and a number of, nanoseconds. We don't have any nanoseconds in our case. Say time dot, what was it? Seconds. That's the offset, and 0. That gives us a naive date time. Let's print that. So it does successfully print it. I mean, the date is correct, but it's 2 hours behind, which makes sense because I'm in Denmark currently, which is 2 hours behind UTC. I believe that's like because we're 1 hour behind London-ish time, and then because of summertime, that adds another hour, I believe. So if you look at time, we have this offset minutes thing. Let's just try to print that and see what it says. No method offset minutes. That's because we just made a new variable called time and basically shadowed our old get time. So that prints 120. That's 2 hours, so that does make sense. So now we need to convert this guy into, we basically need to add the offset to this time down here, right? So how do we do that? You can see if you look at the trait implementations, you can see that naive datetime implements add duration. So that means that we can basically add a duration to our time. So you can say like plus a given number of seconds, a given number of whatever, basically. So if we look at this duration here, it has one that says seconds. Basically lets you create a duration from a given number of seconds. That should be exactly what we want. Is this one in the prelude? I'm not exactly sure. Let's find out. So duration from seconds. Call it offset. Duration is not imported. Let's just import it. I guess the reason it's not imported by default is because there is a type with the same name in the standard library. You want minutes. Oh yeah, you're probably right. Yeah, it was 120, so good catch. Live programming, live pair programming, mob programming. So it expected an I32, but it expected an I64, but it found an I32. So that is because duration, this takes a 64-bit number, but the one we get from Git is a 32-bit. I suppose we should be able to say I64 from like that. You can in Rust also do it like this. I honestly don't know a whole lot about what this syntax actually does, like what are the semantics, because you can also like convert a 64-bit number into a 32-bit number, but that's not necessarily, like you might lose information in that case. And I believe this as operator will just do that without complaining. Whereas the from method that we called before won't do that. So that's usually what I do. And then if it complains that method's not implemented, you can usually call try from instead. So if we try to do that, let's say n is a 64, 1, and then if we say I32 from n, yeah, that doesn't work. You can call try from, which will basically give you an error if the type doesn't fit. So usually this is sort of my preferred way of doing conversion between different number types. So now we have the time, we want to add our offset, print it out, and it works. So that's about like roughly half an hour-ish ago. Let's just do a show on the commit. April 22nd, 26, whoops. Cool. So that basically works. Now we're able to get all the branches. We're able to get the commit of the branch. Casting truncates in Rust as far as I know. Yeah, I think you're right. It scares me a bit that it just does that like without warning you about it. It almost seems un-Rust-ish, sort of. So we're able to get all our branches. We're able to get the commit for the branch, and we're able to get the time of when the branch was made. So let's now make a thing where we gather up all that information, and then we sort the branches, and then we basically let the user step through them one at a time. So I've gotten into trouble by casting a U64 to a usize. It's definitely odd. Yeah. You really have to pay attention when you work with stuff like that, especially if precision matters. I have made like toy games where like some parts of some library used F32s and some other used F64, and in those cases I just like convert back and forth willy-nilly. Let's pull all this stuff into a function. Let's just call it get branches. Returns a result of something. We don't really know what it is yet. For now, let's pass the repo in. We're probably going to need the repository a bunch more places. And what I'm thinking is that we should return a result list of some type, like some struct that basically has just the fields from the branch that we need. Let's just call it branch. We don't want to print to standard out anymore. Right, so what we actually mean is we mean result or error. Let's define our branch type like that. So remember earlier where we saw that stdio result was just sort of a type alias with a fixed result type. Let's add one of those ourselves. Otherwise, we're going to be tired of having to type comma error all the time. When you do this, you just need to sort of fully qualify the second one. Otherwise, it's like you're making a recursive type alias, basically. So this breaks this guy up here. We can just fix it like that. But a sort of cool little trick that I've seen is that if you want to be able to use the result type like this, so without explicitly specifying the error type, but you also want to allow this sort of syntax in cases where you want to actually set the error type. Maybe it's some library error that you're returning and not the one from your repository. You can actually say that your alias, your type alias, has two generic parameters, but the second one defaults to yours, to your error type, and then you can just set that one to E. And now both types, or both signatures, actually works, which is kind of a neat little trick that you can do in your library if you want. All right, so we need to return a vector of branches. Let's say vec branches. Return that one at the end. And then we want to push into it, branches push. Format it nicely here, branches push. It needs to be mutable. There we go. And let's say, what do we want? We definitely want the time in there, right? So time is a naive date time. So normally when you're initializing structs, you do it like this. So the name of the field, colon, the variable. But a neat shorthand is if the variable and the field happen to have the same name, you can leave one of them out and just say time, which is nice. And then we want the commit ID. Whoops, like this. Which I believe was an OID. Use. And we want the name. What type was that? I don't remember. That was bytes. Let's say that we just require that your type is actually UTF-8, then we can just store it as a literal string. I guess it's very uncommon that you have branch names that don't contain UTF-8. So you can create a string from UTF-8 by saying whoa, we just got a sub. Thank you so much. I think that's my first sub. That's really cool. Thanks. Glad you're enjoying the content. Yeah. I should get, like, all streamers have those like animations that pop up on stream and like play music and let you say a quote or whatever. I don't know if that's too silly. I haven't looked into that at all. So from UTF-8 returns either a string or some error of some kind. Lossy, including invalid characters. No, let's just do this one and let's add this error case to our that's annoying. I just noticed that that's a vec there and it's a slice here. Because what we get in this case is a slice of bytes, right? let's try to keep the name as a slice for now. Like that. So then we need a lifetime here. I wonder what is that? Name. No, I don't think that's it. Because I believe the compiler would have been able to refer that, rather infer that. Yeah, so that is borrowed from branch. We have so many tabs. Branch, name from self, name bytes. You know what? Let's just convert into a string and let's allocate. Who cares? String from UTF-8. If you know of a great way to get around this, let me know. What I was thinking was that, so this lifetime here is the lifetime of self. I was kind of hoping that like that was the lifetime repo up here, which it might be, I'm not entirely sure. But it's apparently not this guy. So this is one of the cases where like cloning the name of a branch is probably fine. Like, first of all, this is a command line tool. It doesn't need to be super sort of careful with how much memory it allocates and all that sort of stuff. And if you were thinking like, if we were to like exhaust the amount of memory that we had, you would have to have a gazillion branches, which you probably don't, right? The issue is now that name bytes returns a slice. I believe you can say into vec to turn into a vector. Nope. Slice. Into vec on a box. To vec. So that works, and we pass in the name. And that's obviously a result because the name might contain like non-UTF-8 stuff. From UTF-8 error. And that is probably just some opaque error type. Yeah. Let's add that to our common error keys down here. And then we can unwrap it again. And there we go. All right, so now we're able to return all the branches. This is a very common sort of thing that you'll see in Rust, where you make like an empty vector, and then you make a loop, and then for each iteration of the loop, you just sort of push a thing onto the branch, and then you return it, or onto the vector, and then you return it at the very end. And you can totally write it this way. That's fine. Personally, I like to use the iterator methods as much as possible. And this is basically a map, right? If you make a loop and you return or you do something at each end of the loop iteration, that's exactly what a map does. You could imagine this as like looping over the branches, and for each return, like map that to one of these branch types, and then collecting that into a vector at the very end. So let's do that. What does OK do? Why not just return type branches? Oh, that's a hot topic in Rust at the moment. So we say that we are returning a result, but in like branches is not a result. Branches is just a vector of branches. So we have to actually wrap it into an OK. I don't follow that discussion closely, but there's a lot of like talk in Rust at the moment of making like this syntax not necessary, so that you would be able to just do that. But we're not really going to get into that today. So far, we have to do OK wrapping, which is okay. All right, so let's try to turn this into a map. And then we're going to run into an interesting issue with the question mark thing that I think that would be a nice exercise to see how we can solve that. And then if you actually run into that, which is quite common, then you'll be able to use it. That's all going to make sense later. So let's comment this out, and then let's say we want to make that a map. So it already is an iterator map branch. Let's just say what type it is. So it says it's a result branch type or some git error. All right, let's just do the same unwrapping thing that we did before. Now it says question mark can only be used if we return a result. That totally makes sense, right? Let's just for now say OK of nothing. Now it says type annotations needed, cannot infer type. I've seen this error so many times, and I'm like, but there is no type annotation here. What do you mean? But it means that the compiler can't figure out what error type you actually want to convert into. So it knows that this branch thing is one of these git errors, but it doesn't know like which one it can convert into this guy down here. It can convert into a box error thing. There's a whole bunch of ways that you could go about it. So what I believe you can do up here, you can actually say a result of nothing, and that works. So remember that this result is basically this type alias up here. So it's the same as saying result and then our own error type. And this syntax I discovered a couple of weeks ago. That was new to me. I didn't know that you could specify return types for like literal closures like this. And it is super handy sometimes, especially in this case. So now I think we're basically able to inline, or rather bring back all this stuff. Like that. Put this in an OK. Expected nothing. In this case, you can actually just say underscore, and Rust will just infer what the return type is from this guy. Remember, when it complained earlier, the only thing it was saying was that it missed a type annotation for the error type. It knows what type of like success value you're returning. All right, so now if we say collect into a vec, now we have branches. Almost. We have a list of maybe a branch or an error. So what you could do now is like do sort of a for loop, just like we did before, where you sort of question mark unwrap each of them and then actually accumulate and do all that stuff. There's a super convenient way that you can get around this. If you look at the collect method from the iterator trait, you can see that it works on, or it can collect into any B where B implements from iterator. So if we look at from iterator, this basically takes an iterator that yields items of some type, and then it creates a self. So you can imagine that we can create a vector of anything, or like in this case of branches by doing this. But if we have like an iterator of tuples, like a key value pair, then we can collect that into a hash map, which is really nice, a really nice feature of Rust iterators. But one key thing that you may not know is that into iterator is actually implemented for a result. So that means that if you have an iterator of results, then you can collect that into a single result with the collection type in the OK case and the error type, or rather the first error in the error case. So this means that down here we can basically say result like that, and then use question mark. And now all the way at the top here, this is now the vector that we wanted. So this code is basically equivalent to the for loop stuff that we had before, but here we're using iterators, which is quite a bit more flexible. And you can actually leave off the, you cannot leave off the vec, because it doesn't know what's the collection type that you want. Oh, it does know. Yes, it knows that because we are returning a vec up here. So that's cool. So this will actually work with multiple types of errors in the closure or only one OK type. So this syntax up here is shorthand for typing this. So you can only have one error type, or rather you can have multiple error types inside the closure as long as they can all be converted into your one sort of top level error type. If you want to just use a generic error type, you can use anyhow, the crate anyhow, which gives you basically sort of a dynamically typed wrap all error kind of thing, or you can use the standard box error trait object kind of thing that you see a lot. Oh yeah, and so if imagine if this line returned the error, then that would actually return the result with the first error, and because iterators are lazy, it wouldn't actually keep going, and then down here when we actually collect it into a result, it would get that result that we returned up here, and then that's the result that the question mark would yield, which is exactly the same that our for loop did before. So we keep looping over our iterator, and whenever we hit an error, we bubble it up with the question mark. So these two pieces of code are exactly equivalent. But this, using the iterator, is super convenient. It doesn't make that much difference in this particular case because we're only doing like .map. But you can imagine a more complex case where you had a map and a filter and a fold and whatever. So it is super handy to know. From iterator is really cool. All right. So now we're able to get all the branches from our repository. Could you remove the branches variable, I think? This one? Yeah, no, I'm not sure. Oh yes, in this particular case you can. If you wanted to do like more stuff with it down below, you wouldn't. But yeah, you're absolutely right. Because our function returns sort of the actual result itself, that is what we're collecting into. I think we can even remove the whole result down here. Yep. And Rust can just sort of infer what we want to collect into from the return type of the function, which is neat. Can we get rid of this guy as well? Yes. Oh well, we can get rid of all the code. Rust can just infer it. Yeah, and again, the reason that we can get rid of the turbofish, this operator thing is called the turbofish. The reason that we can get rid of that is because that Rust can infer everything from the return type of our function. So if we were to actually put it into a variable, like that, then it would complain because it doesn't know what type to actually collect into, basically. There we go. Let's see. We are probably going to have to make this one a borrow because we're going to be using our repository to like delete branches and stuff like that. Yeah, so let's take the sort of prompt terminal, right to the terminal main function that we wrote way in the beginning. And actually try to build a small UI around what we've been doing so far. So we put the terminal into raw mode, we get the repository, we get standard in, standard out, we write our prompt. Maybe we should like sort our branches. We're not actually doing that. It would make sense to like find all the ones that are to actually sort them. So in this case, we will have to bind it to a variable. And I do believe we have to say a result vec, like that. So sorting. You can't directly sort on an iterator. The iterator trait is very simple. All you can do is get the next item. So if you want to sort, you need to turn it into some sort of concrete collection type like a vec. It has a whole bunch of sort methods. So it can sort where the thing that is sort of in the vec is orderable. And then there's a whole bunch more. I think the one we want is sort by key. So sort by key takes a mutable self. So we're going to have to declare our vector as mutable. And it takes some closure where the closure takes a t. A t is the thing in the vector. It returns a k where k is orderable. So you can basically think of this as sort of providing an ad hoc thing that you can sort by. We could, if we wanted to, implement ord for our branch and just say, well, compare on the times in this case, or we can just call this sort by key. So we're gonna have to make this guy mutable. Mute branches sort by key branch time, like that. So now it should be sorted by the latest date first, so the oldest date first. Let's just test that quickly. Let branches repo borrow for branch in branches. Go over to the other project, which had a bunch of branches. It prints leaderboard first, which I do believe is the oldest one. Master is definitely the newest one. Let's just say git show leaderboard. That is from 2014. Git show testing is from 2015. So that works. One small tip regarding sorting. You can see that there are these additional sort methods down here called sort unstable. It's not hugely important in our case, but we can actually use sort unstable by key. An unstable sort basically means that if you have objects or like items in your list where the thing that you are sorting by are the same, then those two items will end up in the same place in the sorted list. If that property is true, so if things with the same sort key ends up in the same place, then your sort is stable. If they don't, then your sort is unstable. And it basically means that your sort will be quite a bit faster. And in our case, people aren't going to have multiple branches with the same names anyway, so that doesn't matter. We might as well do the unstable sort. And if you're using Rayon to do like sorting in parallel, that can also do par unstable sort, which is a really fast sort algorithm. I have used that before to troll my colleagues with how fast Rust is at sorting. All right, so we have the branches. put the terminal into raw mode. Then let's do, so we want to loop over each branch and then print out whether or not to like actually delete the branch. For branch in. Let's put the stuff inside. So let's say we want to say the name of the branch. Last commit at like that, and then let's say the user should either able to like what are the action that we actually want to be able to provide for each branch. I'm thinking to put like the letters that they can type in here, so like something like that. I believe this is similar to what you see with Git rebase. So let's say that we want to be able to keep, which I guess is K, delete, which is a D, and get help, which is a question mark. I also think we might get to have like a show, which will basically do like a git show master to like show the message of the commit and the diff and stuff like that, which we might get to. Let's just do these to begin with. Let's also print out the commit hash, branch ID, like that. So we want KD question mark space flush. Then we want to get a character. If that character is Q, so we will allow that as well there. Then we break. All right, so this is just some character, can be anything. We don't really know what it is. So what I'm thinking would be nice is if we have some data type, like some enum, that actually represents the different actions that the user can take. Then we can sort of limit our code in that way, which would be much nicer to deal with than just dealing with raw characters. So let's make that. Let's make a enum. Let's call it branch action. Branch action. What did we have? We had keep, delete, quit, and help. And then it would be really cool if we could just say convert a character into a branch action. So let's do that. There is a trait in the standard library called, we've already looked at it, it's called from, which allows you to convert between types. But in our case, since the user is able to type any character they want, what if they type one that we don't understand? In that case, we would want to be able to fail somehow, or signal to the user that, hey dude, we don't know what you're talking about. So in that case, there is try from and try into, which are basically the same, but where you're able to provide an error type, and then the conversion function actually returns a result instead. So let's implement that, and let's say that you can get a, so impl for character. Branch action, the arrow type is our own arrow type, like that. Can't find trait try from. Try from has incompatible type. That's because we want to swap. We swap these. So we want to be able to create a branch action from a character. For branch action like that. You can also see in the definition of the trait, the type that try from receives is the same type that appears in between these angle brackets, which means we want to put char here because we're converting from a char. Somehow I always get like from backwards in my head. I think into makes more sense, at least when you're implementing it. But oh well, from is usually the default of these two traits, try and, or rather, from and into. You usually implement from because you get try, you get into for free. Whew. Hopefully that made some sort of sense. All right, so we're gonna match. If it's a K, then we return OK, branch action, keep. If it's a D, we return delete. Q, let's quit. And question mark is help. Am I blind? Yes, I am. There we go. So we need an error type that we can actually return. Let's just make a new one. Let's say invalid input on the character. And the display implementation should be invalid input. Don't know what means. Error invalid input on the character. So this special syntax here comes from the this error crate, and it's sort of similar to how you would do string interpolation with the format macro. So here you can see an example of how to do that, and it basically takes the 0th field of this tuple variant. If you have like named fields, then you can refer to them like this. So that's what that means. This is a bit special to the macro that we're using. So now we should be able to say that we convert let action, branch action, try from the character, handle the error. Now we don't need this special case anymore. We can now say match action. And then we need to handle each of them. Let's do quit first. That will just break the loop. Quit, keep, delete, and help, like that. So let's say in the case that you do help, let's say that we want to print, what do we want to print? Let's just like print a description of what each of the letters mean, each on their own line. I'm thinking how best to do that. You can make multi-line strings in Rust with this sort of wonky syntax. So everything in between is now just a normal string, but you can put quotes inside it without having to escape them. You don't need to do that. And you can also have new lines in between, and it sort of keeps the string going. So this is called a raw string, I believe. And if you want, so it basically looks for this hash and then a quote. So if you want another one of these inside your string, I believe if you want, sometimes you can add like additional one of these if you want 3, or you can sort of keep it going like that. It's rare, but this is one way to make multi-line strings in Rust. You could also like make a vector of strings and then like join them together. But then we're going to be like allocating and stuff like that, which we don't really want. I suppose we could also just call write multiple times. How about we do that? And we don't need to bother with these funky strings, but now you know they exist. Here are what the commands mean. Let's print them in the same order with it before. K is keep the branch. D is delete the branch. Q is quit. I don't know why I keep writing quiet. Question mark is show this help text. And then we flush. Let's just write something in these 2 cases just so we can see that they're actually working. So it shows master. We can say question mark to see the help. In this case, we actually want to ask for input again. So you see, because the input that we got from the user was help, and then we basically, because we don't do anything else, we sort of fall out of the loop, like we stop working on the branch basically. So you could do that with another loop. Basically what we want to do is, as long as they ask for help, we want to keep giving them a new prompt, basically. I suppose you could do that with a loop. You could also, which I think I'm going to do, is make a function called get fn get branch action from user. It returns a result branch action. Move this stuff inside. Let's keep the prompt outside, because I imagine this function is going to be recursive. So do we want to show the prompt every time? Yeah, let's do that. Let's put the prompt inside of it as well. And so a whole bunch of stuff. So it's complaining that it doesn't find standard out. Let's give it that. Standard out is a standard out. And it needs the branch. And it needs standard in. I believe standard in needs to be mutable as well. No, standard in is a bytes. Like that. Cin bytes. And we cannot call break. So this is interesting. Previously we were inside of a loop. Remember we had a loop here before, or rather we were inside the for loop. So we were able to break there. But we can't really break anymore. Let's say that if we run out of input, we just call ourselves again, like that. Match arms have incompatible types. So basically, if we run out of input from standard in, which we never should, is that possible? I don't think so. Then we just call ourselves recursively again and try to get more input. Let's say this one returns what does this one do? That basically returns the action, right? And then if we get a help, then we print this text, and then we call this function again. So this basically means that as long as they keep asking for help, we'll do the same loop. So this is okay. All this okay wrapping. Can't borrow standard in as mutable. And that compiles. Let's see if it works. Get input from user. So this needs to be a mutable reference. And so the reason that these need to be mutable references is because we're calling write standard out, and because we're calling next on standard in. It's a bit weird. Like, we basically know that help is never going to be returned here. It almost feels like we need two enums, right? Or we need some earlier like matching on the actual character here. And then if the character is H, then we do this sort of special stuff. So we don't have a branch action that's help. Because that means that every time we match on the kind of action, then we have to consider help, even though it will never be help, because in the case it is, then we recurse and call again. Yeah, let's fix that. So let's remove the help action, and then let's match, say if the character is H, then we show this stuff. Otherwise, we do this stuff we did before, like that. And we remove help from there, like that. So that means that this guy up here doesn't need to consider the help option anymore, because it'll never happen. And we're sort of guaranteed from the type system now that it won't happen, which is nice. Let's run it, see if we've broken everything. Question mark. Error, invalid input. Whoops, that's because this is not H, this is question mark. Oh yeah, this is funny. So now you see my terminal is all wonky. The input is like off to the side. This sometimes happens if you're in, if you put your terminal into raw mode and it doesn't get like put back into normal mode. In that case, you can type reset and then it's back to normal. That actually does make sense. We should probably handle that. And basically, so in this case, we got an error here, right? And that returned early from main. which means we never got to actually disable raw mode, which is probably not what we want. We would probably want to disable raw mode regardless if there's an error or not. So let's say the main doesn't return a result anymore. And then let's make a closure that is immediately invoked. So this creates a closure and then immediately invokes it. So that's just sort of a nice way to have a try block almost, if you will. And we say like that. And then regardless, we disable raw mode. And then we have the same issue before. We need to tell it what type of error is it here, because Rust doesn't know. I believe we can do it like that. No. Result. Like that. That works. So this is basically fully qualifying the OK type. I believe we can also do, if you wanted to use the fancy sort of closure syntax that we learned about earlier, I think we can just do that. Yeah. And then it complains that there's an unused result. That's because we need to actually handle this guy here, right? So we say let result. We disable raw mode first. If there's an OK, then we don't care, everything's good. Whereas if there is an error, then let's print it system an error and say exit, I believe it's in. So exit with a non-zero status code. Like that. I think that should work. So we try question mark, it shows the help, and it immediately just sort of keeps going. We're forgetting a new line here though, I have to add that. And on a K it just quits, which makes sense because we're not actually doing anything here. So let's quickly address the new line business. That is here. I believe we need to add an additional new line there. No, here. And our terminal did successfully get out of raw mode, because otherwise the prompt would be all the way to the right over here. That works, and K goes out. Very cool. We could go all nuts and add like colors and all kinds of things, but let's not bother with that. I do think this guy is quite long though, so let's just let's cut that down a little bit. Branch name was a string. Can you do this? 10. So this basically takes this is a range, the range operator, or range indexing rather, I guess. So this is from the first character up to, but not including the 10th character. If you want it inclusive, you can add an equal sign there. And then we have to borrow, because otherwise we'd be moving the contents out of the string, which we don't want to do. So now it prints a, whoa, byte in his hand is out of bounds of master. Ah, wrong one. So this is the name of the branch. We obviously want to be doing that on, basically the clamping on the, or rather not the clamping, but like the offsetting on the OID. So OID we need to turn into a string, and if you remember from earlier, it implemented display, and anything that implements display we can also turn into a string by saying to string, we're doing an extra allocation here, I believe, maybe by like converting it into a string, then taking a sub slice of that string and then interpolating it up here, but nah, it's not a big deal. Our terminal got fucked up again because we panicked this time, which means we didn't get to disable raw mode. Let's not worry about panics. So we are successfully showing fewer characters here. So that works, and Q quits. So just if you're interested and you wanted to add color, the way you could do that, so many branches, let's close out some of these branches, or tabs. Crossterm. So crossterm is the library that we use to enable and disable raw mode on our terminal. It also has a whole bunch of stuff for like coloring of the text, both foreground and background. So this is the kind of stuff that you would play around with if you wanted to actually colorize stuff. This part of my prompt, fun fact, is actually made using this exact same set of libraries. I'm not sure if it's crossterm, but it's definitely Git 2. I like to try and write everything in Rust. Like, who wants to do Bash, right? All right, so quit. Let's try to handle each of these actions. Quit, as we saw, it actually printed a % here. That's because we're not ending with a new line. So let's just do that. Right. Standard out. Like that. Get help a few times. Quit. There we go. No more weird %. In case of keep, we don't actually need to do anything, right? It's only on delete. So what we want to get up is the repository, and I believe it has a method called delete branch. Delete branch, delete an existing branch. So that means we need the original branch. Interesting. So notice that our branch type, if we say like branch.delete, like that doesn't work, because this branch is our own sort of branch wrapper struct that we made earlier, right? So we almost need to carry the original branch with us, which I hope we can do. Let's try. So we need a branch. In this case, we can't call it branch because we already have a type called branch. So let's just fully qualify it. Say git to branch. It needs a lifetime. That's the repo. Like that. Can we just put the branch there? Branch doesn't implement debug. Oh well. Let's remove the debug implementation. So if we wanted to, we could add our own debug implementation that treats the, we could do something like this. The issue is that we can't derive debug on a struct where all the fields don't implement debug itself. We could add our own implementation and just sort of treat this branch field special, but let's not bother with that. If we get into a situation where we need the debug trait, then we can look into it. So now we actually have the branch. So now we have to say branch.branch.delete. It can't be borrowed as mutable. which is because you need to say mute there. I can never remember what the syntax for these for loops are. There we go. So the issue was that by default, a for loop will calls into iter, I believe. Uses the into iterator trait. And I believe there's also a mutable version of that somewhere. Into iter. Yeah, so we implement, vector implements into iterator 3 times, once for actually moving the iterator, so taking ownership. In this case, you get an owned t for each iteration of the loop. It implements it for references, where you get a reference. And finally, it implements it for mutable references, and then you get, well, mutable constants. So since the into iterator trait is sort of implicitly called by this for syntax, we need to tell it this will by default do the owned version. If we put an ampersand there, it's the borrowed version. And apparently if we put an ampersand in mute, then it's the mutable version. Can you delete the master branch in a Git repo? Does anyone in chat know what happens if you delete the master branch? Let's find out. So I'm basically just making a new repository and trying to delete the master branch to see what happens. Commit. Git branch delete master. Cannot delete master. Nope. I suppose it would make sense if we just ignored the master branch, basically. How would we do that? Branches, name. We can use filter map instead. If name no, we cannot. God damn it. What I was thinking was, so on iterator, there is a method called filter map that takes, that's sort of like map, but where each, like where the function returns an option instead, and then it will, so it'll sort of do the map that maybe can fail for some error that we don't really care about. And then filter map will actually just remove all the none cases. So that's a way to sort of do a map, but maybe there's some elements that you just want to ignore. So I'm thinking of how we would actually do this, because it gets a bit more complicated when we have results in the mix. Let's just try to put in a filter. So this is now a result. So we don't actually care about the error handling, right? So let's just say if let OK branch is a branch, then true, else false. Whoops. If let, what is branch now? Now it's just a branch. So this basically says that if there is an error, well, just keep that. Like the filter just ignores that. We could also say false down here, but that means that we'll be ignoring any errors down here, which we don't want. We want to keep the error. You could say is okay, but the key here is that we actually want the branch. We need to say like branch.name equals master, right? Rather, branch name is not master. So now we're sort of removing the master branch. You're totally right. If we just wanted to have a filter that removed all the errors, then we could say branch dot is okay. And so is okay is a method on result that returns basically the same as matching, and then returning true if it's okay. I'm not sure if there's a simpler way to like write that. Maybe there's like a filter result kind of thing. Doesn't seem like it. But I mean, this works. So now actually imagine that if we run it over here, it should just exit immediately because there are no branches, right? We should probably show sort of a message to the user if that's the case. It's just sort of weird. It seems like it doesn't even work. It almost appears broken. So let's add that. Let branches map maybe. Yeah, but the issue is that map. So if you map over a list or an iterator that contains 10 items, you'll always get 10 items out. Map doesn't let you remove items basically. And in this case, we need to remove master. In some cases, we would be able to use filter map, which basically lets us sort of do a map and remove at the same time. But in this case, we're required that our function returns, map on the result. Yeah, I think we probably could do that. Branch map b dot unwrap or true. Branch as ref. Yeah, we can do that. I mean, is that better code than this? I'm not sure. Is this sort of what you had in mind? Yeah. I do want to highlight one thing though, because the error that we encountered is actually a fairly common one. So branch is a result, and we try to call map on that. Then map. And notice that map takes an owned self, which is not what we have. We have a borrowed self. We have a borrowed result. Whenever you get an error like this, you usually get them on option or result in this case. You can usually call .asRef, asRef, and that basically borrows the result and then gives you an owned result with borrowed contents. So you can think of this as, instead of borrowing the whole result, you sort of move the borrows inside the result. And it doesn't do any copying or cloning or anything like that. It basically just does a pattern match and then creates sort of owned OKs and errors in this case. So that means that we now have an owned result. Notice there's no ampersand in here, which means that now we can call map, because map signature takes an owned self. .asRef, and that works. There's also asRef mute, or asmute rather, which does the same but for mutable references. There's also asDref and a whole bunch more. So whenever you see an error like this, try putting in asref. If that doesn't work, try some of the other ones. Honestly, sometimes I just go through all of them until one of them works, and I'm like, all right, I guess that's the one. What does the ref keyword do? So the ref keyword is a bit of old syntax that was necessary in an earlier version of Rust. It basically means that you are sort of matching on, so self is a result, and so you're matching on the content and you want to borrow the contents. So in this case, X will be a reference. Otherwise, if you didn't do this, it would be like, hey, dude, you're trying to move X out of self, which you cannot do because self is only a reference. So ref is a way that you can explicitly say, and I only want a borrow to the contents. This was necessary in an earlier version of Rust. I don't believe it is necessary anymore. I think there was a feature that landed some releases ago called match ergonomics that I believe removed the need for the ref keyword. Some people still prefer it for explicitness, but in most cases in modern Rust, you don't need it anymore. So that's what that means. All right, so if we don't have any branches, say if branches is empty, then do this. Otherwise, we will write found no branches. We ignore master. Like that. And we want a final new line. There we go. Let's jump over here. This was the project that we've been going back and forth between, which has many more branches. So this says leaderboard, D. In this case, we don't really handle D. It did go through all the branches though. What's up? We actually did accidentally delete all the branches just now. That's great. We do have the commit hashes. That was very lucky that we actually put those in the message. Because I apparently typed D a whole bunch of times. We don't actually print the input that the user gave. Maybe we should do that. So a cool thing about Git is that you can't really lose stuff. So if you accidentally delete a branch, it's not lost. If you know the commit ID, the branch still exists. You can just create a new branch pointing to that commit. Branches are not like, if you're sort of first starting out with Git, it's useful to think of branches as like folders almost. And whenever you create a new branch, Git sort of copies the contents of your repository into this new folder. And when you then switch branches, Git automatically like swaps out these folders. Turns out that's not what branches are at all. Branches are basically just pointers into the commit graph, and everything you do in Git just sort of adds to the commit graph. It's really hard, maybe impossible, I'm not quite sure, to actually delete stuff from the commit branch. So if we just say, so even though we just deleted this leaderboard branch, if we copy the SHA and we do git show, you can see that it's still totally there. And we can just say git branch leaderboard at that commit. And now if we move over to that branch, you can see it's now at that commit from 2014. So nothing's actually lost. Let's just do the same for each of these branches. Let's see if we can make a vim macro. Go to the beginning of the line, close paren, delete, get branch, find parens, delete. Yep. There we go. Now all our branches are back from before. Nice. Let's just keep this file around. Leaderboard, add that commit in case we need it. And then let's run our tool again. Okay. So Q doesn't actually quit all the way out. Let's first, so there's two bugs that we just discovered, right? The first one is that we should probably print the character that the user types so that so they can see it. And then Q, you actually have to hit Q for each branch. We should probably, K is really what Q does right now, right? It keeps the branch. Q should quit all the way out and just be done. So if we quit, that is actually what we want to do on keep, right? Quit should basically return okay, nothing, because that will return out of this function, get down here, disable raw mode, and then end the program. So that's that. Then we want to print the input. So that's the input that we have there. Let's say write standard out. I think it's just the character. Like that. Now I don't think we need that one anymore, because otherwise we'd basically be printing two new lines right after each other, which seems wrong. Let's give it a shot. So there's two new lines because K currently prints a new line. There we go. All the branches are still there. If we say Q, it quits. Question mark shows the help text. So we're on leaderboard. Let's say we want to delete it. Hit D. Cannot delete as it is head. Interesting. So that makes sense. We're currently on the leaderboard branch, which means we can't delete it. Not sure if there's a good way to resolve that. Should we ignore the branch if it's head? I guess so. We could also switch you over to master. That's kind of odd though. Let's ignore the branch if it is the current branch. Should we also print it to the user? What do you think, chat? What should we do in this case? How do we handle deleting the branch that they are on? Let's just test that the other stuff actually works. So leaderboard, delete it, testing, keep, Emacs, keep, help, keep. And testing is gone. So it actually works. So with this one bug left, we've basically set out to create what we set out to in the beginning, which is cool. One thing I'm thinking though, it would be nice if you delete a branch. If you do that by accident, we could have a field, an action to undo. to undo the last branch you just did, or rather the last delete that you just did. And we just saw that because of how Git works, that is trivial. But I think what we could just do is instead print like some text saying, if you did this by accidentally, if you did this accidentally, here's the command that you can run to restore the branch. So let's do that. Let's just make a small to-do list up here. So we need to figure out how to handle deleting the current branch and printing undo message like that. So an undo message, that's this guy here. What does delete look like? What does its signature look like? It takes a mutable self. I was wondering if it like moved self. In that case, we wouldn't be able to access branch anymore, but it doesn't. So that's cool. Which means that we could say something like, we should probably also print like some confirmation that the branch was actually deleted. Deleted branch, branch name, to undo, run git branch name and the ID. Like that. So delete leaderboard. And it didn't show because we forgot to recompile. There we go. It's quite a long message. It includes the entire branch, but we don't really care. So we quit out, we run this. So leaderboard is gone, run this, whoops. And leaderboard is back. Nice. That was that guy. Then printing the current branch. Let's say, yeah, I think I have it. So let's, on our branch, say we have a field on this guy. We have a field for whether or not it is the current branch, and if it is, we skip it, but we up here we print the message to the user saying that we're skipping it. Let's do that. Would it be possible to just have an undo action instead, so you didn't have to copy paste out? Yeah, that would be totally possible. I don't think it will actually be too hard to do. We have all the things we need here. You know what? Let's just do that. Let's add it to our to-do list. Add undo action. I'm imagining that we're going to have some option variable thing that has the sort of previous branch that we just iterated over. And then if you run an undo action, then we apply that somehow to recreate the branch. And obviously, if there is nothing to undo, you're on the first branch, but you ask to undo, we just kind of show an error. So that's probably fun to add. Let's do that. But first, let's ignore the current branch. So we have get branch action from user. What's the function you actually want? This guy, get branches. How do we know if a git branch is the current branch? Is head. Determine if the current local branch is pointed at by head. That sounds like exactly what we want. Is head bool Use of moved value branch. Oh, we actually store the entire branch there. Why did we do that? Ah, so we can delete it. All right, then we don't need this as head anymore. I mean, we could also just not have our own branch struct at all. The reason we do is just to make these 3 fields more accessible, so you don't have to do this dance every time. So it's basically a convenience sort of thing. But in that case, I guess it would actually make more sense to not have this method be branch.branch, but instead just branch.delete. And then we can almost consider this field private and these other fields public. So if we were designing a library, the consumer would never know that we were wrapping an actual Git branch. Let's do that. I feel like that's cleaner anyway. Repo fn delete. Signature is going to be very similar to this guy. Branch.delete. Would making branch field a reference solve the last problem? No, I don't think so. It needs to be owned regardless, because otherwise you can imagine that we're getting a repository and then we're pulling out the branch, and this is an owned value. I mean, Rust Analyzer doesn't know, but it is a branch. So if we take a reference to that here, that means that, so the actual branch variable that we're pointing to lives as long as this iterator here, right? But we're collecting the contents of the iterator into a vector and returning that. But I mean, the actual reference is dropped. It's not owned by anything else. So that would not work. Maybe I'm misunderstanding you, but I don't think so. And we have a type error somewhere. All right. So what it's saying now is that the error that we get from delete is a Git error, but what we say that we return. So remember, the syntax is shorthand for like this. So there's a couple of ways that you can do this. You can say question mark and then okay like this. So we're basically doing the sort of type conversion that the question mark operator does. And this totally works. You could do this. I personally find that it reads a bit like awkwardly, like okay, and then there's a question mark in the middle. That's sort of weird. What I usually do is I say map error from like that. And that does the exact same thing. So that method is never used. That's because we're not calling it from there. There we go. And now it's basically transparent to the user, the fact that we're keeping a Git branch around. And we wanted the is head. There we go. That could also just be a method that delegates to the branch. So could all of these technically. I don't think that makes a huge difference. If you were doing a library, that would probably be a better way, so that, for example, if someone doesn't need the time field, then you won't spend time computing it. In our case, I wouldn't worry about it. So we say if branch is head, and that's a field, not a method. Then we will print ignoring because it is the current branch. I think that works. Let's give it a shot. We technically need to not be on master. So it says ignoring leaderboard because it's the current branch. Things are actually working. Then we can keep testing. We can delete Emacs, get help, keep, and be done. And we have the command to restore there. And Emacs is back. Sweet. Delete the current branch. All right. An undo action. How are we going to do that? So I imagine that we're going to have some sort of branch action undo thing down here. Let's add a case for that. Down here. Do. Make it U. We need to handle that case here. And there's some place where we actually print the prompt. We need to include a U now as well. Wait. This code is silly. We don't need to do this. Yeah. So we're matching on the action and then returning the exact same one. So the reason that we had this lying around is way back when we were handling the help text as a branch action. Then we need to do special stuff on the help action, but we don't actually need that anymore. Refactoring. Okay, U is undo last deleted branch. You could come up with some like abstraction over all the commands to actually sort of, because remember each time we add a new variant to this enum, we have to remember to add a new help line in the help text here. And currently we just have to remember to do that, which means we're bound to forget it. You could come up with, like you could have some method that returned all the variants of the enum, and then for each variant you could have like a help text that it could print. For now, I don't think we're going to deal with that. But that is one way that you could sort of improve the design of this little library. All right. So we want to, so for each loop, we want to say like a previous branch. Let deleted, like previous deleted branch or deleted branch, or undo state. I don't know. And then if you, so this needs to be mutable. If you delete a branch, then we say deleted branch is a sum of the branch. And use of a moved value. That's because here we're moving the branch variable into this option, but then we're referring to it later down the road, which we can't. But in this case, it's not a huge deal. We just moved it down. whether we write this to the terminal first or we store off the undo state first, it doesn't really matter. So in this case, we get an undo. We have to match on if let some branch is deleted branch. If there's nothing, we need to print an error. Undo is special because we're currently like our prompt expects us to basically deal with, so if we keep that one, delete that one. So currently our prompt is dealing with this 2, right? Whereas when I type a character, it sort of applies that character to this particular branch, right? Whereas undo is different. Undo just sort of does a side effect, but the next prompt that comes up is still 2. So it's sort of similar to help in that sense. Because if we just were to actually undo the deletion here, then it would go on to the next branch and basically ignore the branch that we were sort of currently operating on, right? Which makes me think that we probably need to handle undo differently, or like we need to have a way to communicate to this for loop whether or not we should go to the next iteration of the loop. I am not sure what the best approach is. Does the problem make sense? Is there anybody who sees like a smart way around it? The issue is basically we want to perform a side effect here, but like the next time we get around, we basically need to get like perform a side effect and then get another branch action. What if you undo twice? That should not be possible. Can we abuse that fact? What if we let's just try to code it this way, and then let's get undo working, and then we can see that that bug is actually there when we got to test it. So this is a branch. Like that. How do we actually create a branch in Git? Branch name target is a commit, force is a bool. Do we have a commit? Go branch, the branch name. The commit and force. If false is true and a reference already exists with the given name, it'll be replaced. It's not a huge deal in our case because we just deleted the branch, but let's just set it to false for now. So we need a commit. Do we have a way of getting that? Does it have to be in a for loop? I don't really know Rust, only through Haskell subreddit. So if you know how functional you're going, but I will use recursion instead somehow. Yeah, we actually do something very similar down in the, so we have this function, get branch action from user, and there we have a special case for the, if they type question mark. In that case, we print the help text and then we get another action basically. So this means that they can type question mark as many times as they want. I'm thinking we're gonna have a situation, something like it. It just sort of feels wrong to add like another special case to this function with undo. So we need a commit for a branch. A branch, we had the OID. Reference. What's it called? Target. OID. I believe on the repo that you can say find commit with an OID and a commit. That returns a commit, which seems to be what we want. Let's say, so our branch type has the OID. Let commit is repo. What's it called? Find commit. Find commit. Branch ID. Yeah. This needs to be deleted. No, that's this guy. All right, so what it's complaining about here is, so this one has type option mute branch, and then we're trying to move it. Can we borrow it? What type does it have now? Not sure this is gonna work. It does work. So what I was wondering was that that we were going to get some sort of ownership error because we're like, because maybe the reference wouldn't live long enough or something like that. But it doesn't seem to be the case. So it takes a lot of practice to sort of wrap your head around the ownership and borrowing. So in most cases, you just sort of write a bit of code as if ownership was not a thing. And then the compiler basically tells you how to fix it. And then over time, as you get more practice, you'll learn to be able to anticipate when things are going to give you different kinds of errors, and then you can sort of write the correct code the first time. But that takes practice and is not really possible in all cases. But it seems to be working in this case. So we're able to find the commit. And that is actually a commit. Then we can branch. So it expected a reference, but I found a commit. There we go. So that creates the branch. So now we are successfully recreating the branch. And if you want to undo, but there is nothing to undo, then that's an error. Let's just print that out. didn't find anything to undo. Oh, hi, since when are you back? Since last week. I took a bit of a break, but with the stay inside times, I thought it would be fun to start streaming again. I try to stream like once a week-ish. I also announce on Twitter ahead of time when I'm streaming, so go ahead and follow me there if you want to know. So you should not be able to undo twice, probably. So can we say, whoa, what the hell happened? So regardless of what happens in here, we set deleted branch back to none, like that. Compile, go over here, give it a shot. Let's say that we delete testing, and then we want to undo, quit, and testing is in fact still there. It is on the right commit, B5. Let's do the same again, but this time delete it, and then keep the rest, and testing is gone. So it is actually working. So we now have undo. However, the bug that we discussed before, if we delete testing, so now I want to delete the Emacs branch. But if I also want to undo the deletion of the testing branch, whoops. So we delete Emacs, and we want to undo that. I hit U, and we're done. So I never got a chance to actually act on the to branch, right? Which is annoying. That's a bug. How do you fix that? If Rust had go-tos, we could fix it. You could imagine you had up here, you had like a label like start. And down here, if you undo, you do like a go-to start. That would work, right? Because then people basically get another chance to pick their input. I'm thinking. All right, we're just gonna try stuff. So what if we, instead of looping this way, recursion? Yeah, the problem is where though? That means we need to make another function. You know what? That probably is the safest, or rather the nicest thing. I was gonna make like a variable up here called current branch, like a mutable variable called current branch, starting out as none. And then for each iteration of the loop, we assign that variable. And then you could like, each of these would like, I don't even know how it was gonna work. Let's do recursion. So it should be possible to do with recursion if we pass in the iterator. Wait. I'm not sure. Let's try. fn, what are we going to call the function? Act on branch. That's not a good name. Does chat have suggestions for a better name? So it's gonna do something like this in between. Whoops. 1,000 type errors. Let's take them one at a time. So it needs a mutable reference to a branch. Mute branch. And the reason it needs to be mutable is because we need to be able to call a delete down here, which takes a mutable reference to self. And we have to return a result at the end. Have to pass in standard out. Maybe it would be nice to have like some app struct or something that we were on that had fields for standard in and standard out. That way we didn't need to pass them back and forth all the time. It's not a huge deal. That is a potential refactoring that we could make. Bring this guy back. We need standard in as well. And that needs to be a bytes iterator from standard in. Can't borrow standard in as mutable. What? Consider changing this to mute standard out. All right. So standard in and standard out are already mutable references. So we try to take a mutable reference to a mutable reference, which we cannot do. There we go. Non-exhaustive pattern match. That makes sense. Let's try to add each of them back. Deleted branch is not found. Let's wait with that one. And so we need to sort of carry this deleted branch thing between iterations, right? You could do the functional way and return it, but I mean, we're in Rust, so we're just going to mutate everything and then just pass this guy in as a mutable reference. Deleted branch, mute option, mute branch, I think. Repo. It's probably a lot of fields. So the issue there was the reason we need, so we want the mute here, because if we don't have the mute here, that means that deleted branches will effectively be passed into this function and then be gone from the perspective of the caller. Like they won't be able to access it later down the road. But they need to be basically passing that in to every call to act on. So we need to be able to mutate it basically. But down here, we're assigning, so deleted branch is a mutable reference to an option, and we're assigning that just a straight up option, which doesn't match, right? So the types don't line up. We need a mutable option, but we're getting just an option. So what you need to do in this case, I don't even think you can put a mute there. Apparently you can. I'm honestly not sure if that works. The way you normally fix it is you put a deref at the front. So that will like dereference the mutable pointer and then actually assign to it. So let's see if we can actually call this function. I'm not sure if we can. So it takes the branch, standard out, standard in. Those need to be mutable. Deleted branch, mute. Repo borrowed. It worked. So how do we then, fuck, it didn't work. Lifetimes mismatch. Haha. It's been a while since we had a nasty lifetime error. All right, so I think I know how to fix this. Let's see. No. These two types have different lifetimes. So, if I understand this correctly, the issue is that, so we're trying to assign this branch, this variable, to this deleted branch thing. And so branch is currently a borrow, mutable reference, and we're trying to assign it to deleted branch. As far as I understand, the compiler can't sort of guarantee that this reference and this reference in here lives for the same duration. So maybe this one goes out of scope before, or rather is dropped before this one is, in which case the data inside this option would become invalid. At least I think that's how what it's saying. However, that should mean that you should be able to fix it like that, but you're not. So this is basically a way for you to say branch lives for tick A, and the mutable branch reference inside deleted branch also lives for tick A. So therefore you should be able to assign to it like this. But that does not work. I must be misunderstanding something. Deleted branch. Let's try to read it to see what it actually says. Lifetime mismatch. These two types are declared with different lifetimes. But data from deleted branch flows into branch. What if branch was not a mutable reference, but an owned reference? Then we would be able to assign it, I think. So if this guy is not mutable here, that means this guy becomes owned. And this guy in here is now just a branch. Still a lifetime mismatch. What's it saying? These two types are declared with different lifetimes. Is it because our branch struct has a lifetime on it here that we're basically leaving off up here? Is that why? So we say A. Clear this one. Expected mutable reference. Can I borrow branch is mutable? All right. Whew. Okay, so I think what's going on is our branch. So our branch has basically a lifetime or a reference inside it, due to the fact that the actual Git branch has a reference inside it. So it is generic over some lifetime, which means that our branch is generic over some lifetime. And that means that there's basically an implicit lifetime here that that we can sort of leave off, and then Rust will try to infer it for us. However, the bug that we had before, so remember we have a hidden lifetime here, and we also have one here. But apparently Rust did not infer these two hidden lifetimes to be the same. Whereas if we annotate them with tick A, we say, hey dude, it's fine, they are the same. So now that works. You can almost imagine it as it looked like this before, right? So the branch that comes in lives for tick A, and the branch that we assign to the deleted branch lives for tick B, some other lifetime. And that's a type error. These two types are not the same. A and B can be totally different, which means that one could go out of scope before the other. But by declaring them as being the same type, that does fix it. And I actually think now we should be able to change this one. I mean, we could change this one back to a mutable reference, like we had before. Yeah, but that's not necessary. That should be fine. So the key here is that after calling undo, we can not return. We can basically call, we can call act on branch again, passing in that deleted branch repo, and I think that should just work. So if you do an undo, we basically repeat the same action for the branch again. Let's compile. And run. So we want to delete Emacs, undo. It shows 2 again. Let's keep git branch, and Emacs is still there. Let's verify that our delete stuff still works. So we delete Emacs, and we keep 2, and now Emacs is gone. And it's successfully still ignoring leaderboard. So there we go, that works. Recursion solved it. That was it on our to-do list, I believe. This guy doesn't need to be mutable. So that was basically it. That was sort of what we set out to create in the beginning. There's a whole bunch of ways that you could improve this if you wanted to. You could support options for maybe to include remote branches, and then instead of using the delete branch function to actually delete it, then it'll like do the git push : name of the branch thing to actually delete the branch on the remote server. You could have some configuration around ignore branches that were committed to recently. You could possibly have a config file with a list of long-lived branches that are always ignored. There's a whole bunch of ways that you could take this, right? I mean, you could also just add more color, because color is always good, right? However, I think we're gonna leave it here. We've been going for like 3.5 hours, which seems like a pretty good duration. So if there's any questions in the chat, now is your time. Otherwise, we're going to be pushing it up. Nice. I do have to learn some C with ref and pointer management to learn Rust. No, you don't. I have only written C for a couple of weeks in university, like 5-6 years ago, for the operating systems class. And basically the only thing that class taught me was that I never wanted to write C ever again. And I am not good at C at all. Like, I know it. I've written maybe 100 lines of C total. So no, you absolutely don't. You need to sort of wrap your head around pointers and a bit of that stuff. But the key difference between Rust and C is that the compiler in Rust doesn't let you do things that lead to undefined behavior, basically. Whereas in C, there's no help. So as long as you're not doing unsafe code in Rust, you're safe. Well, obviously, as long as you don't do unsafe, you're safe. So no, you don't need to learn C. What should we rank the commit message? Initial working implementation. So maybe it would be fun to just briefly go over some ways that if you wanted to improve this. I do want to mention, so I'm going to push the code up to GitHub. If you want to like play around and make it more into like a fully fledged CLI app with like config and options and all that stuff, there's a really cool crate called struct that basically allows you to define a data structure, a struct, and then sort of derive all the command line argument parsing code from that. So in this case, they define an option or an opt struct with a whole bunch of fields. And you can then call from args to basically get an instance of this struct. And if there's anything wrong with the input, you get like a super nicely formatted help text, and it automatically stitches out all the flags and does all that stuff. So if you want to like play around with this code and add in more functionality, I highly recommend you check out struct opt. It's really great. Let's put it on GitHub. I'm gonna do this after the stream is over. I don't need to log in now. And then I'm just gonna post the link in chat. Then you can check it out. Otherwise, if there's anything else we were to improve, I probably would put like this act on branch and some of these functions into like an abstract kind of thing that had fields for standard in and standard out, just so we didn't need to pass them back and forth all the time. That's a minor improvement, not really a huge deal. Otherwise, I think I'm actually pretty happy with the design. We have no unwraps, which is pretty great for a Rust library. So hopefully this gave you sort of some insight into how to actually develop a sort of not just a toy project in Rust. So with that said, if there's no more questions, that was it for today. You're welcome to follow me on the Twitters or here on Twitch. Those links are all down below. I expect to stream like once a week. But I'm gonna tweet about it when I know. Otherwise, thanks for a great stream. I feel like we got a lot of stuff done. This is actually a tool that I would like to use in my day-to-day work. I feel like there was some good questions and some good interaction in the chat. So thanks for the people who stopped by, and I'm gonna hang around a bit in the chat if you have any more questions. Otherwise, thanks and take care. See ya.